What if entire galaxy clusters are moving together toward one unknown direction? That unsettling idea is called dark flow. If it were real, something beyond the visible universe might be shaping the motion of matter itself. And that would challenge one of the deepest assumptions in modern cosmology. On the largest scales, the universe is supposed to look roughly uniform. Galaxies and clusters can move because of gravity, but those motions should become more random across vast distances. They should not all seem to drift together toward one mysterious point. That is why dark flow caused such a shock. The idea gained attention in 2008, when researchers suggested that galaxy clusters shared a large common motion. They used subtle signals in the cosmic microwave background to infer that movement. At first, it looked like a major cosmological breakthrough. Suddenly, the universe seemed less stable and less predictable than expected. Dark flow does not mean galaxies are outrunning cosmic expansion. It means they may have an extra shared motion on top of that expansion. Imagine an inflating balloon with dots moving outward, but also sliding together in one extra direction. That coordinated drift is what made the claim feel so extraordinary. To measure this effect, scientists studied the kinematic Sunyaev-Zel'dovich effect. Hot gas in galaxy clusters can slightly alter the background radiation passing through it. But this signal is extremely faint and difficult to separate from noise. That weakness made the dark flow claim powerful, but also very vulnerable to criticism. If dark flow were real, the implications would be enormous. Some scientists wondered if structures beyond the observable universe were somehow pulling on matter inside it. Others linked it to inflation or even to a larger cosmic landscape. What began as a velocity anomaly quickly became a possible crack in our model of reality. That is why the phrase "beyond the horizon" became so important. It did not mean we had seen another universe. It meant unseen mass outside our observable limits might still be influencing what we can detect. That possibility transformed dark flow from a technical debate into a haunting cosmic mystery. Then came the backlash. Many researchers argued the result could be caused by noise, bias, or analysis errors. The signals were so faint that even small mistakes could create the illusion of a giant cosmic motion. In cosmology, weak data can sometimes generate very dramatic stories. The biggest challenge came from the Planck mission. Its analysis did not support the strong large-scale dark flow signal claimed earlier. That did not erase all galaxy motions, of course, but it seriously weakened the idea that enormous regions of the universe were moving together in one strange direction. This changed the debate completely. Dark flow was no longer treated as a likely discovery, but as a disputed possibility. Some scientists still considered it interesting, while many others saw it as unconfirmed or probably exaggerated. The mystery remained alive, but its scientific status became much more fragile. Even if dark flow turns out to be wrong, it still matters. It revealed how difficult it is to measure motion on the largest cosmic scales. It also showed how easily faint signals can be overinterpreted when the stakes are enormous. Sometimes science advances most when a dramatic claim is challenged. Dark flow also captured the imagination because it touched something deeply human, the fear that the universe does not end where we think it does. The idea that something beyond our cosmic horizon might be tugging on everything we know is both mathematical and mythic. That is why the concept still lingers. Today, dark flow stands between discovery and caution. It may have been a real clue, a statistical illusion, or a lesson in the limits of observation. Either way, it reminds us that the universe is hardest to understand at its largest scales, and sometimes the greatest mysteries come from almost invisible signals. So what was dark flow really? A hidden force beyond the observable universe, or one of astronomy's most seductive false alarms? The debate still lives on. Like this video, subscribe to World of Mysteries, and share it if you want more cosmic mysteries like this.